communication. If you remember, in our previous module, we have actually discussed what are different types of modulation: amplitude, frequency and phase. So if you vary amplitude, you'll get amplitude modulation. If you vary phase, you'll get phase modulation, and if you vary frequency, then you'll get frequency modulation for your carrier wave. So now let's analyze how can I generate amplitude modulation, what are the various mathematical equations involved in amplitude modulation, and how can I detect my amplitude modulation. So dear students, what is amplitude modulation? It is a system of modulation in which the amplitude of your high frequency carrier wave is made proportional to the amplitude of your audio frequency modulating voltage. Why voltage? Yes, we have already discussed that either it can be a voltage or current when you talk about your modulating signal, because it is nothing but a form of electromagnetic waves. So let's see, I have two signals. I have a carrier signal and I have a modulating signal. So I'll denote your carrier signal with C of t, which is nothing but a sinusoidal signal. So I can say it is AC sine of omega ct. Then another signal what you have is your actual audio signal, which is nothing but your modulating signal. Hence I can say that m of t can be represented as am sine of omega mt, which is nothing but your original signal. Perfect. So I have my carrier signal, I have my modulating signal. Now what I'm supposed to do in amplitude modulation, I'm supposed to vary the amplitude of your carrier signal with respect to your information signal. So I'm supposed to add carrier with your modulating signal, and the variation has to be with respect to your carrier signal. Hence I'm supposed to multiply sine of omega ct. Now we know that C of t is nothing but AC sine of omega ct, and your m of t is nothing but am sine of omega mt. So when I multiply this, I can take sine omega ct common. So from the first bracket I have AC, and the second bracket will remain out to be am sine of omega mt. Now dear students, understand the next step what I am supposed to do. I will take out AC common. So when I take out AC common, from the first part of the bracket 1 is remaining, and from the another part I have am by AC. Now I will take this very beautiful term which is nothing but am by AC, and I call it to be modulation index. Okay, so what is the requirement of this modulation index? I'll explain you in this upcoming modules. So I have taken that am by AC to be a modulation index denoted by the term mu. Now when you talk about this, what I'm supposed to do ahead? Now I can easily multiply AC sine of omega ct inside the bracket. Yes, so when I multiply the AC sine of omega ct inside the bracket, and I'm remaining with the term that is sine of omega ct into sine of omega mt, which is nothing but sine of A into sine of B. Perfect. So when I substitute the formula of sine of A into sine of B, the result what I'll get will be half cos of A minus B minus cos of A plus B. So when you analyze this equation, you will get three different terms, dear students. Yes, the first term, that is AC sine of omega ct. Perfect, which is nothing but your carrier signal. So nothing great had happened here. But when you see the other two terms, if you compare with your sinusoidal equation, mu AC by 2 is nothing but the amplitude. Yes, so I have actually varied my amplitude, right? And the frequency, if you see, one is cos of omega c minus omega m, and another is cos of omega c plus omega m. Right, dear students? So the three terms can be written as unmodulated carrier wave. Why? Because there is nothing happening in that equation. But the second and the third is actually modulating. The second is actually cos of omega c minus omega m. So that will be in the later half. Hence I said it to be lower sideband, and needless to say, cos of omega c plus omega m can be referred as upper sideband. So for amplitude modulation, I need to remember three different equations. One is your carrier wave, and another two are your frequency bands. One is your lower sideband and another is your upper sideband, having frequencies omega c plus omega m, and omega c minus omega m. Perfect, dear students. So when you talk about this equation, let's try to analyze this with a graph. So I have three different equations, one having amplitude AC, another having amplitude mu AC by 2, and the third one is also having amplitude mu AC by 2. So when I draw the frequency spectrum, so I will plot amplitude versus frequency. The first is directly AC, yes, having frequency at omega c. Another is mu AC by 2, which will be a bit lesser than AC. Perfect. And hence, since the frequency is omega c minus omega m, it is at the left hand side. And the last one will be mu AC by 2, having frequency omega c plus omega m. Now how I degenerate this amplitude modulation, I'll explain you in the next module. Thank you.